Welcome. This is a video to show you how to pass parameters different ways. In MIPS 3, we use very simple parameter passing, such as in int print, where we passed arguments in the registers. We reminded you that the A registers and the V registers are typically the registers for parameter passing. You really should avoid using the S registers and T registers for parameter passing. So in this style of parameter passing, things behave like they do with the system calls, where predominantly you used A1, A0, and also V0, V1. So we know how to do the parameter passing for int print. We also know how to do it for add2, because again we are passing parameters in the registers. Now sum 3 is different because you must pass the parameters on the stack and return the value in V0. So let's remind you of what the stack looks like. In MIPS, in memory, there's a region dedicated to the stack, and this is a high address, and here's a low address down here. So the stack moves toward low memory from high memory. So the top of the stack is really right here. This is the top of the stack. We know how stacks work. If I want to add another value to the stack, then I have to add it down here, which means I must find an address for this one, get an address for that, and store this. This is in memory, so to store something in really means store a word from a register into this address in memory. Notice that this address in memory does not have a name associated with it. The address should be in a register. So there is a register in the MIPS machine that holds the address of the top of the stack. This register is called SP. SP as in stack pointer. And again, it points to the top element on the stack. Whatever is at this address is a value that's on the stack. So what must we do? The way that we access the stack is always through the SP register. So when we want to see what's there, we've got to use SP. What if I want to take the top value off? How would we do that? Well, this is memory, and we got to put it into a register. So it's just a load word. Oh, come on now. It's just a load. What am I doing? It's just a load word instruction. Load word into a register of your choice. From memory, what address are we using? We're using the address that's in SP. So SP is really the base address register, and with 0 offset. So that says whatever this is pointing to is an address. SP contains an address. Use that address. This is a 0. Use that address, and we're going to copy what's here into a register. And if we want to pop the stack, which means we no longer need to use this. This instruction must be followed by one where we change the stack top pointer to be here and now. So what happens to the stack top pointer? It needs to be bigger than it was before, so we must add 4 to it. So the other instruction that you would do would be add I, add I to stack top pointer we're going to take the stack top pointer and add 4 to it. So that with that, the new position of stack pointer will be up here, and by definition, whatever SP is pointing to is the then top of the stack. All right. Now, conversely, if we want to add something to the stack, what must we do? Well, SP points to SP points to a value that's on the stack. So if we want to add a value to the stack, what has to be done first? Well, we've got to move SP from here. Did not mean to do that. Got to move SP from here down to here. So we're going to say the top of the stack is no longer here. I must create a space for this. How do we create this space? Well, we take SP and we must change it by 4. Because the stack is growing downward, we've got to subtract 4 from it. So if I want to put a new value in, I must first add I stack pointer dollar stack pointer, and I must subtract a 4. So this is a minus 4. So I must decrease it by 4, which brings it down here. And then I can store what's in my register into memory address by stack pointer. So what is it we just learned? Let's go back in and see what we've just learned. What we've just learned is this sequence here is what you do when you push a value onto the stack. This sequence is what you do when you pop a value from the stack. Okay? Notice that you're really doing the same thing but in reverse order. When I want to push, I must change the stack pointer and then store into memory using the stack pointer as a memory address. When I want to pop, I must first get the data from memory, from the stack, and place it into a register. Then I must change the stack pointer so that it is no longer pointing to that slot, because that slot is no longer contains the top of the stack. So I achieve that by adding 4 to it. All right? So that's the first thing. I think we'll stop right here, and you really have to be tight on that sequence.